Okay, in this lecture, we're going to keep moving through the section 1.6 material on applications of linear systems. And in this example, we're going to look at an application in economics. So as an example, let's consider the following. Suppose that we have an economy that can be divided into three sectors, say chemicals and minerals, fuel and power, and machinery. Now, chemicals, we are told, will sell 30% of its output to fuels, 50% to machinery, and they retain the rest. Whereas fuels sells 80% of its output to chemicals, 10% to machinery, and retains the rest. And machinery sells 40% of its outputs to chemicals, 40% to fuels, and retains the rest. So in part A, we're asked to construct an exchange table for this economy. So what we would typically do to start describing the flow of sales and purchases through this economy, we would try to visualize this by considering maybe a flow diagram. So here, our economy has three sectors: chemicals and metals, which I'm going to denote as just C, say for chemicals for short; fuel and power, which I will denote as F for short; and machinery, which I will denote as M for short. So to visualize this economy, we could think about visualizing our three sectors, chemicals and metals, fuel and power, and machinery, as, say, three nodes, or these three distinct sets or sectors. And let's think about the flow or purchases and sales between these different sectors in the economy. So we are told, first off, that chemicals sells 30% of its output to fuels. So from chemicals, the output being sold to fuels would be 30% of its output. So we indicate that by drawing this directed arrow from chemicals to fuels. And the 30% of its output being sold, we would denote on that arrow as 0.3 or 30%. Whereas chemicals sells 50% to machinery. So from chemicals to machinery, we can draw an arrow with 50% of its output. And then we're told the chemical and metal sector retains the remaining of its output. So let's think about what remains. We've sold 30% and 50%, which is a total of 80% of their output. So the remaining 20% of their output remains with chemicals. So we can draw a little arrow from chemicals and metals back to itself, indicating that 20% stays there. Now we're also told that fuels sells 80% of its output to chemicals. So from fuels to chemicals, 80% of the output is sold. 10% goes to machinery. So from fuels to machinery, we have 10%. So that is a total of 90% being sold to other sectors. And they retain the rest, which would be the remaining 10%. And finally, we're told that machinery sells 40% of its outputs to chemicals. So from machinery to chemicals, we have 40%. 40% to fuels, so from machinery to fuels, another 40%. And so that's a total of 80%. So then the remaining 20% they retain. So this is sort of a flow diagram that illustrates what's happening with this economy. And we're told to construct what's called an exchange table for this economy. So we want to summarize what we've illustrated in this picture in a table. So for our exchange table, let's consider the following. So here, let us consider the exchange table. where we had three different sectors: chemicals and metals, fuel and power, and machinery. And the outputs for each of these three sectors are being purchased by different sectors within our economy. So we'll include a purchased by column. And here, since there's only three sectors within this economy, so each output could be purchased by one of the same sectors, either chemicals and metals, fuel and power, or machinery. So let's look at our columns for this table. So we have our first column representing the output from coal. And for each row in that column, we're going to indicate what share was purchased by each of these sectors. So for our first row, first column of this table, we're indicating the share of, or the percentage of output from coal purchased by coal itself. So the arrow from C back to itself was 0.2. So we would have a 0.2 here. Now moving to the second row in that first column, we're looking for the proportion of coal output which was purchased by the fuel and power sector. So looking at from coal to fuel and power, we had a value of 0.3. And then for our last row in this first column, we're looking for the percentage of output from coal that was purchased by machinery. So looking at the arrow from coal to machinery, we have 50% or 0.5. So notice that the sum of the entries in this first column has to be 1, since 100% of the output had to be purchased by one of these three sectors. So reading along the first column, we can see where the output of this coal sector is going. Now, if we do the same thing, let's look at our second column. So we're looking at what proportion of the outputs from fuel and power was first going to coal. So from fuel and power to coal, we had 0.8. From fuel and power back to fuel and power, we had 0.1. And from fuel and power to machinery, we also had 0.1. So again, notice that the sum of the entries in this column has to sum to 1, so that 100% of the output is accounted for. So for our last column, from the output of the machinery sector, the percentage purchased by the chemicals and metals sector would be, let's see, 0.4, so indicated here from machinery to chemicals and metals. The percentage of machinery purchased by the fuel and power sector, so from machinery to fuel and power, was another 0.4. And we know our last entry has to be 0.2, so that the sum of this column is 1. We can also see that from our diagram above, from metal back, or machineries back to itself, we have this 0.2. Okay. So this is an exchange table, which is summarizing the exchange of goods between these three sectors in the economy. So this was part A. We wanted that exchange table. And in the second part of this problem, which is going to be continued on the next page, we are asked to find a system of linear equations that would lead to prices at which each sector's income would match its expenses. So these prices set where a sector's income would be equal to its expenses are sometimes called equilibrium prices. And then once we have our linear system, we are also asked to write the augmented matrix, which could be row reduced, to find those equilibrium prices. So let's start by introducing a little bit of notation here. There's prices that we're interested in solving for. So let's introduce some variables for these prices. So I'm going to let P sub C, P sub F, and P sub M denote the prices of the total annual outputs of the chemical, fuel, and machinery sectors. So if we're interested in determining these equilibrium prices, well, we need to determine the price at which a given sector's income is equal to its expenses. So let's consider our first sector, C, which was chemicals and metals, I believe. So their total income will be the price of their total annual outputs, which we were calling P sub C. Now that has to equal its total expenses. So let's think about how to calculate the expenses here. So looking back at our exchange table, the coal sector is purchasing 20% of its own annual output, 80% of the annual output of the fuel and power sector, and 40% of the annual output from the machinery sector. So if we have the prices for the total annual outputs for each of these sectors, we can form the following equation for the total amount that the coal sector is spending. So they are purchasing 20% of their own total annual outcome, which we were calling P sub C, plus, 80% of the total annual outcome from the fuel sector, plus 40% of the total annual outcome from the machinery sector. So in order for that amount they're spending to equal the total amount that's incoming, we set those two quantities equal to each other. This is how we find an equilibrium price. Now we need to have this income matching the expense for each sector to get equilibrium prices. So let's look next at the fuel sector. So for fuel, their total income is going to be the price for their total annual output. And this has to equal the total amount they're spending. So looking back at our change table, well, fuel was purchasing 30% of coal's total annual output. They were purchasing 10% of their own total annual output, and they were purchasing 40% of machinery's total annual output. And lastly, for the machinery sector, their total annual income would be the price for their total annual output, which has to equal their expenses. So looking back at our change table, they were purchasing 50% of the output from the coal sector, 10% of the output from the fuel sector, and 20% of the output from the machinery sector. So here we have a system of linear equations, but notice in each of these equations, well, we have some variable which appears on both sides of our equation. So to simplify this system, well, we might move all of our variables to one side of the equation to make this a little simpler. So for our first equation involving the coal sector, I'm going to move everything to the left-hand side of our equation. So I had 1 P sub C, I'm subtracting 0.2 P sub C, which will leave me with 0.8 P sub C minus 0.8 P sub F minus 0.4 P sub M has to equal 0. Now doing the same with our second equation, and keeping the order of my variables the same, well, I might want P sub C to be the first variable appearing in my second equation. So if I move everything to the left-hand side, I have a negative 0.3 P sub C. I had a 1 P sub F, and then I'm subtracting my 0.1 P sub F. So I'll have plus 0.9 P sub F, and then minus 0.4 P sub M has to equal 0. And then simplifying my last equation, still keeping the order of my variables, if I want P sub C as the first variable, I would have negative 0.5 P sub C minus 0.1 P sub F. And then I had 1 P sub M. I'm subtracting my 0.2 P sub M. So that leaves me with a 0.8 P sub M has to equal to 0. So this is a system of linear equations. Notice this is a homogeneous linear system since each of our equations is set equal to 0. And we were told here to find that system of equations. And then also write the augmented matrix, which could be row reduced to find our prices. So expressing this as an augmented matrix, we would have for our first row 0.8, negative 0.8, negative 0.4, and 0. For our second row, negative 0.3, 0.9, and negative 0.4, 0. And for our third row, negative 0.5, negative 0.1, and 0.8, 0. So in this example, if we needed to, we could row reduce this matrix to find the equilibrium prices P sub C, P sub F, and P sub M. It's a little bit messy to do in this case. Namely here, notice that each of our rows involves decimals. Now one easy way to eliminate these decimals and get integer values, we'll notice that all of our entries could be considered as tenths, like for instance, our 0.8 is 8 tenths, negative 8 tenths, negative 4 tenths. So if you multiplied each row through by 10, you could reduce each entry to an integer value, which would then give you a matrix which is easier to work with, and then could be solved.